So now we have to do this theorem, right? And we're going to do it quite quickly because we really are trying to move along. But we have to prove that given any flow and any cut, the flow across the cut can exceed the capacity of the cut. And we want to prove that given a current flow, you can either get a better flow or you can get a matching cut. Everybody understand the two things we need to prove? Given a current flow, we get a better flow or we get a matching cut. Yes, we're going to do it. We're going to do it proof by example. All right? All right, so, right, this is exactly what I said before. The flow witnesses that you can achieve this flow, and the cut witnesses that you can't get a better flow. Right? And so first, let's not spend too much time on this. You can sort of prove by induction that given any flow and any cut, we can talk about how much is flowing across the cut. It's the total flowing across minus whatever's flowing back, right? Because stuff going in a circle doesn't matter. And we can prove by induction that for any cut, that's the same. And why is that? Because each node, the flow in equals the flow out. And the way you would actually formally prove it is you would take one node where the flow in equals the flow out, and you would move it from this side of the cut to this side of the cut, or vice versa. And you see that by doing it, the value of the cut doesn't change, right? Because for this local node, the flow in equals the flow out. Does that kind of make sense? Right? So anyway, let's skip over all that because I think it's pretty straightforward. Right? That's just moving one guy. And so now our goal, remember, is we have a current flow and we get a better flow. We've seen that we build the augmentation graph, we get a better flow. But now we have a current flow and there is no path. Right? So now our goal is to find a matching cut. Everybody get what we're doing here? Yeah. Right? This is a flow which we're claiming is maximum. We build the augmentation graph, and there's no path, so we're going to form a cut. And so what the cut's going to be is, and I apologize, this cut is a dumb example because S is all by itself, but it's not always by itself, right? And what you do is in this graph, you do a depth first search or breadth first search, and you find out where can I reach from S, right? And if there's a path from S to a node, that means I can push more water to that node, right? Along this path, I can be pushing more flow. And if there's not a path to a node from S, then you can't push more water to it. Right? So what are we going to have our cut be? Well, the use side is everybody that can get more water, can get more flow. Right? Everybody reachable in this augmentation graph. And here is going to be everybody that's not reachable. Right? Everybody, that makes sense? This augmentation graph is where you can put more flow. And if from S you can get more flow there, then it's on this side. And then clearly S is on this side. Why? Because you can get flow from S to S. And clearly T is not on this side because if there was a path there, then we would get a better flow. Right? So that's our cut. Right? And then we're going to do it real here quick again. The point is we want to prove, here's our cut. And we want here's our current flow this way, right? This way we have some capacity and some flow. And here coming back, there's some capacity and some flow. And we want to prove that this flow is at capacity, right? And we want to prove that this flow has no flow whatsoever, right? And why is that? Well, if you could have more flow here, then there would be an edge in the augmentation graph from the u to the v, right? Here, like if the flow was less than the capacity, then we could we can get more flow in this direction. And so this would be an edge in the augmentation graph, right? But what is our claim? Is that u is reachable in the augmentation graph from S, and v is not reachable. Well, then there can't be an edge here, right? Does that make sense? But, well, this cut, by definition, is these are the nodes that are reachable from S, right? And these are the nodes not reachable from S in the augmentation graph, right? So that means there can't be an edge in the augmentation graph from u to v. Because if u is reachable, then so would v, right? So that says you can't have these augmentation edges. And if you don't have this edge, that means that this is at capacity, right? And if you don't have this edge, then that means that this flow is zero, right? Because if there was flow here, if there was flow flowing this way, if there was flow flowing back across the cut, then I could push more forward by undoing that flow, right? Does that make sense?
Why are we doing these pictures?
We're doing these pictures because we want to prove that if this was our cut that we defined, that the value of the flow equals the value of the cut. So if every edge going across the cut is at capacity, and every edge coming back is at zero, then the value of the flow is the sum of the capacities, right? And the value of the cut is the sum of these capacities, so they're the same, right? Why can't you get more from Toronto to Berkeley? Is, well, if you look at the edges going from Canada to the States, they're all at capacity, and nobody's coming back, right? Everybody kind of get that?
The augmentation graph, where you have so you're doing a cut in the augmentation graph or the regular graph?
Well, it's the same cut here, and these edges are looking at it in the augmentation graph, and these edges are looking at it in the flow graph. And so we're saying for this edge, how much flow do we have across this edge? Well, we're here in the augmentation graph. We can't have this edge in the augmentation graph. So you can't have a lack of flow in this edge, yeah? I'm just saying, yeah, locally, if there was flow here, then I would put an augmentation edge this way, because locally I could change the flow this way. Right? These edges, this edge has to do with what's happening globally, right? But these edges, it's just locally, can I change the flow in this edge, right? And if there was flow this way, then I could augment the flow on this edge that direction. And then there would be an edge here, but there can't be an edge there.
So this augmentation graph doesn't exist?
The augmentation does, but these edges don't. Anyway, I wouldn't worry about it too much. I want to spend more time on other topics. And I think that's kind of, all right, so let's just conclude on this. What's the problem with this algorithm? The one problem is that we don't have the problem that you get stuck in a local optimal, right? That doesn't happen.